Today's lecture is on dampproofing. One of the basic requirements of a building is that it should remain dry or free from the moisture traveling through the walls, roofs or floors, right? So dampness is the presence of this hygroscopic or gravitational moisture, right? So dampness gives rise to unhygienic conditions apart from the reduction in the strength of the structural components of the building. So the damp prevention is one of the important factors of the building design. So every building should be damp proof. Okay, we have to ensure that every building is damp proof. So provision of the damp proof courses prevent the entry of moisture in the buildings. So the building structure should remain dry is one of the basic requirements in all buildings. So if this condition is not satisfied, it is likely that building may become uninhabitable and unsafe from the structural point of view. So hence, in order to prevent the entry of damp into a building, the courses known as a dampproofing courses are provided at various levels of entry of damp into a building. So this, you can see here this is the rising damp occurs in a building. So rising damp in a building may be defined as the, you can see, as upward flow of moisture through a permeable wall, as you can see in this figure here, permeable wall structure. The moisture being derived from the groundwater. Okay, all the moisture from the groundwater is derived. Okay, and it is the upwards flow of moisture through a permeable wall structure. So the moisture rises through the pores. Okay, pores, that is a capillaries in the masonry. So the rising damp varies in severity depending on several factors, including the level of the groundwater, okay, the pore structure of the masonry materials, that is the bricks, stone, mortars. So, okay, so as you can see here, this is the concrete foundation, and this is the moisture which has been rising into the wall. Okay, so this is the failed damp proof course, which is a rising damp, that is a moisture moving upwards from the groundwater into the building. So the moisture is moving upwards from the groundwater. The moisture is moving upwards into the buildings. Okay, so the damp proof plaster and skirting boards and floor is provided. So this is the impermeable insulation which is provided here. So this is the intact damp proofing course. Okay, damp proofing course is provided here, which stops the rising damp. Okay, so this DPC is provided. Okay, this DPC is provided so as to stop the rising damp. Okay, it is installed at a minimum 150 mm above the ground. Next is the causes of dampness. So there are various causes of dampness, such as a moisture rising up the walls from the ground. So all the structures are found on the soils, okay, and the substructure is embedded into it, right? So if the soil is pervious, the moisture constantly travels through it. So even in the case if impervious soils, lot of soil moisture may be present. So this moisture may rise up into the walls and the floors through capillary action. So groundwater rise will also result in the moisture entry into the building through walls and floors. So the ground on which the building is constructed may be of the soils, which easily allows water to pass. So the building materials used for foundation absorb the moisture by capillary action. Then we have the action of the rain. So rain travels from the wall top. So if the wall tops, okay, are not properly protected from the rain penetration, the rain will enter the wall and will travel down. So leaking roofs will also permit water to enter. Okay, so the action of the rain, if the faces of the wall exposed to heavy showers of rain are not suitably protected, they become the sources of entry of dampness in a structure. So rain beating against the external walls, the heavy showers of the rain may beat against the external faces of the wall, and if the walls are not properly treated, right, moisture will enter the wall, causing dampness in the interiors. So if the balconies and chhaja protections do not have proper outward slope, water will accumulate, right? Water will accumulate on this and could ultimately enter the walls through their junction. So this moisture travel will completely deface the interior decoration of the walls. Next is the exposed tops of the walls. So the parapet walls and the compound walls should be provided with a damp proof course on the exposed tops. Next is condensation. So due to the condensation of the atmospheric moisture, water is deposited on the walls, floors and ceilings. So this moisture may cause dampness. So the process of the condensation takes place when a warm humid air is cooled. So this is due to the fact that cool air can cause less invisible water vapor than the warm air. So the moisture is deposited on the walls, floors and ceiling. Then we have the miscellaneous causes of dampness, like moisture may enter, okay, to the various miscellaneous causes like the poor drainage at the building site, right? Imperfect orientation, like walls getting less sunlight and heavy showers may remain damp. So imperfect roof slope, okay, so especially in the case of the flat roofs, then defective construction, imperfect wall jointings, joints in the roofs, defective throating, etc. Then absorption of the walls from the defective rainwater pipes. So if the structure is located on a site which cannot be easily drained off, the dampness will enter the structure. So the orientation of a building is also an important factor. So the walls obtaining, as I told, less sunshine and heavy showers of rain are liable to become damp. Okay, so the dampness is caused due to bad workmanship also in construction, such as a defective rainwater pipe connections, defective joints in the roofs and improper connections of the walls. You can see here, this is a figure. You can see the damp rising through the floors. Okay, so the damp rising through, this is the damp rising through the foundations, and it is a penetration by the driven rain. Okay, then effects of dampness. So dampness gives rise to the breeding of mosquitoes and creates unhealthy living conditions. So travel of moisture through walls and ceilings may cause unsightly patches. Okay, so moisture travel may cause softening and crumbling of the plaster, especially this lime plaster. So the wall decoration is damaged, which is a very difficult and costly to repair. So continuous presence of moisture in the walls may cause efflorescence, resulting in the disintegration of the bricks, stones, tiles, okay, and consequent reduction in the strength. So the flooring also will get loosened, okay, because of the reduction in the addition when moisture enters through the floors. So the timber fittings like the doors, windows, okay, almirahs coming in contact okay, with the damp walls, damp floors will get deteriorated because of the warping, buckling, okay, and dry rotting of the timber. So then electrical fittings also gets deteriorated, giving rise to the leakage of electricity and consequent danger of the short circuiting. So this floor coverings also get damaged. So dampness promotes an accelerated growth of the termites. It results in the softening and crumbling of the plaster. Okay, continuous presence of moisture in the walls may cause efflorescence, which may result in the disintegration of the stones, bricks, tiles, and the strength of the wall is also reduced. So these are the different effects of dampness. You can see here, this is the figure showing effect of dampness. You can see the walls, how it is damaged. So next is the requirements of an ideal material for damp proofing. So the first is the material should be durable. Okay, then the damp proofing course should remain effective during useful life of a building. Then the material should be perfectly impervious. Then the material should be capable of resisting safely the loads coming onto it. The material should be such that it is capable to carry out the leak-proof jointing work, and the material should be free from salts like sulfides, chlorides and nitrites. Next we have the various materials which are used for damp proofing. So the first one is a hot bitumen. So this is a highly flexible material which can be applied with minimum thickness of 3 mm. Okay, it is placed on the bedding of the concrete or mortar while in hot conditions. Next we have the bituminous felt. So this is a flexible material. It is easy to lay and available in rolls of normal wall width. It is laid on a layer of the cement mortar. Then we have the metal sheets. So the sheets of the lead copper, aluminium can be used as a damp-proofing course. Okay, so these sheets, they are flexible type. So the lead sheets are quite flexible. Okay, so their thickness should be such that the weight is not less than 20 kg per meter square. So they are laid similar to the bituminous felts. Okay, so the surfaces of the lid coming in contact with lime and cement are likely to get corroded. Okay, so hence the metals should be protected by coating of the bitumen paint. Aluminium sheets can be used for damp proofing, and they should be protected with a layer of the bitumen. Then we have the cement concrete. So this cement concrete, a 1:2:4 mix is generally provided at the plinth level to work as a damp proofing course. So the thickness may vary from 40 mm to 150 mm, and it stops the rising of the water by capillary action. Then we have the mortar. So cement mortar 1:3 is used as a bedding layer for housing other damp proofing course materials. Okay, a small quantity of lime may be added. Okay, may be added to increase the workability of the mortar. So in water used for mixing, it is 75 gm of soft soap, okay, is dissolved per liter of water. So the mortar may be used for the plaster work on the external walls. Then we have the bricks. Okay, the dense bricks absorbing water less than 4.5% of their weight can be used for the damp proofing at places where the damp is not excessive. So then we have the techniques and methods of damp prevention. Okay, so the following precautions should be taken to prevent the dampness in the buildings. There is a site should be located on high ground and well drained soil to safeguard against the foundation dampness. It should be ensured that the water level is at least 3 meters below the surface of the ground. All the exposed walls should be of sufficient thickness to safeguard against the rain penetration. Okay, so if walls are of bricks, they should be at least 30 centimeter thickness. Then techniques and methods of damp prevention. So the bricks of superior quality which are free from defects such as the cracks, flaws, lump of limestones should be used. Okay, they should not absorb water more than 1/8 of their own weight when soaked in water for 24 hours. The good quality cement mortars should be used to produce a definite pattern and perfect bond in building units throughout the construction work. Next, coming to prevention of dampness. So the use of the damp proofing courses or membranes. So this consists of introducing a water repellent material, a membrane or damp proofing course, okay, DPC, between the source of the dampness and a part of the building ascending to it. So these are the layers of the membrane of water repellent material which are interposed in the building structure at all locations. So this damp proofing course of suitable materials should be provided at appropriate location for the effective use. So basically this DPC is provided to prevent, as I told, the water rising from the subsoil and getting into the different parts of the building. So this is the use of the damp proofing course of membranes. Okay, it will prevent the rising moisture in the walls. Okay, so the damp proofing course may consist of the flexible materials such as the bitumen, mastic asphalt, okay, bituminous felts, the plastic or the polythene sheets, metal sheets, cement mortar. Okay, so the damp proofing course may be provided either horizontally, as you can see here, the damp proofing course is provided horizontally or vertically also in floors, walls. So the general principles should be kept in mind while providing the DPC. So what are these general principles which we need to keep in mind? The first one is a damp proofing course should cover the full thickness of the walls excluding rendering. So the mortar bed supporting the DPC, okay, the mortar bed which is supporting the DPC, that is a damp proofing course, should be leveled. Okay, it should be properly leveled and even and should be free from projections so that the DPC is not damaged. So the DPC should be so laid that a continuous projection is provided. Okay, so at junctions and corners of the walls, the horizontal DPC should be laid continuous. Okay, so when a horizontal DPC, that is that of a flow, is continue to a vertical face, a cement concrete fillet, okay, of 7.5 centimeter radius should be provided at the junction. So DPC should be not be exposed on the wall surface, otherwise it may get damaged during the finishing work. So as you can see here, this is the damp-proofing course which is laid, okay, and this is the fillet which is provided. Next, use of damp-proofing course or membrane. So while providing the damp-proofing course in buildings, as I told, the following principles which you need to keep in mind is the DPC should cover the full thickness of the walls. The mortar bed upon which the DPC is laid should be level, even and free from projections. Next, we have the integral damp-proofing treatment as one of the preventive measure of dampness. It is like this consists of adding certain waterproofing compounds, okay, of materials to the concrete mix so that it becomes impermeable. So this waterproofing compounds may be in three forms, like the compounds made of chalk, talc, fuller's earth, which may fill the voids of concrete under the mechanical action principle. Then compounds like alkaline silicates, aluminum silicates, calcium chlorides work on chemical action, that is, they react chemically and fill in the pores to act as a water resistance. Then compounds like soap, petroleum oils, fatty acids compounds, okay, work on repulsion principles, that is, they are used as admixtures in concrete to react with it and become water repellent. Next is a pressure grout. So cementation, that is a cementation, it is a process of forcing the cement grout, that is a mix of cement, sand, water, under pressure into the cracks, voids present in the structural components and ground. So this pressure grouting, okay, this consists of forcing the cement grout under pressure into the cracks, voids, that is fissures present in the structural components of the building or the ground. So thus the structural components and the foundations which are liable to moisture penetrations are consolidated, and thus are made water penetration resistant. Okay, so this method is quite effective in checking the seepage of the raised ground water through foundations and substructure of a building. So all the components of a structure in general and the foundations which are liable to moisture penetrations, they are consolidated and so made water resistant by this process. Okay, so drilling is done at selected points in the structure, and the cement grout of sufficiently thin consistency is forced under the pressure to ensure complete penetration onto the cracks. Okay, so this makes the structure watertight and restores the stability and the strength. Then we have the gunneting, shotcreting or gunneting. So this consists of depositing under pressure an impervious layer of rich cement mortar over the exposed surfaces for waterproofing over pipes for resisting the water pressure. So cement mortar consists of 1:3 cement sand mix, which is shot on the cleaned surface with the help of a cement gun, okay, under pressure. The nozzle of the machine, okay, is kept at a distance 75 to 90 centimeters from the surface to be gunneted. So the mortar mix, okay, the mortar mix of the desired consistency and thickness can be deposited to get an impervious layer. The layer should be properly cured for at least 10 days. Okay, as you can see here, this is a shotcreting or gunneting which is done on site. So any surface which is to be treated is first thoroughly cleaned of any dirt, grease or loose particles and then fully wetted. The mix of the cement and sand is then shot under pressure of 2 to 3 kg per centimeter square by holding the nozzle of the cement gun at least 75 to 99 centimeters from the wall surface. So the necessary quality of water is added by means of regulating valve soon after the mixture comes out from the cement gun. Okay, so mix of the desired consistency and thickness can be sprayed to get an impervious layer. The impervious surface should be watered for about 10 days. So by this technique, the impervious layer of high compressive strength can be obtained, that is 28 days strength can be obtained, and so it is useful method for reconditioning, repairing the old concrete works, bricks and the masonry works which have been deteriorated. Next, coming to methods of damp proofing. So if the level of the ground floor is in level with the ground surface or just above it, as you can see, the DPC is provided, the damp proofing course is provided. Okay, so the material should be flexible and it should be stepped vertically through the wall to meet the damp proofing course of the solid floor. Then if the two ground floors, okay, at different levels, they are connected by an internal wall. If it is connected, if two ground floors which are at different levels, they are connected by an internal wall, the dampproofing course is provided, as you can see in this figure here. Okay, so the dampproofing course on the internal wall is in level with the lower flow level. So in order to prevent the rising of moisture from the adjacent ground, the air drains are provided. So an air drain is a narrow hollow space which is constructed parallel to the external wall. The width of the air drain is about 200 mm to 300 mm, as you can see in this figure here. This is an air drain which is provided. This is the foundation concrete. This is the DPC layer and the air drain which is provided here. So the openings with gratings are provided at regular intervals for the passage of air. Okay, so these openings are provided, as you can see in this figure, for the passage of air. That is, opening at regular intervals with gratings are provided. So the top of the air drain is covered by an RCC slab, as you can see. Top of this air drain, this is covered with an RCC slab here. Okay, so the horizontal and vertical dampproofing courses are provided as shown in this figure. Okay, horizontal and vertical dampproofing courses are provided. Okay, so with this I end my lecture.